Okay. So good morning and good evening, everyone. Welcome to Global Artificial Intelligence Conference. I hope everyone is doing well and staying safe. I want to thank the organizer for giving me the opportunity to present. And thank you, K.S. Murthy, for the kind introduction. Um, I'm joining in from Boston, Massachusetts, and the title of my today's talk is Data Science and Machine Learning with an emphasis on banking industry. To start off, here is an outline of my today's talk. We will start with an introduction of data science and machine learning, artificial intelligence and big data, industries and applications of data science, tools and evolving capabilities, data and uniqueness and challenges. Today, I would be focusing on one use cases for classification algorithm from banking vertical, where we demonstrate the use case on predicting probability of bank loan default. And finally, we will close the talk with a short conclusion. I want to provide a quick introduction on 4 buzzwords in the world of data. So let's start with data science. Data science continues to evolve as one of the most promising and in-demand career paths for skilled professionals. It is the field of study that combines domain expertise, programming skills, and knowledge of mathematics and statistics to extract meaningful insights from structured and unstructured data. Machine learning algorithms are responsible for the vast majority of the artificial intelligence advancements and applications you hear about. Machine learning provides systems the ability to automatically learn and improve from experience without being explicitly programmed. Machine learning is the process that powers many of the services we use today. Recommendation engines on Amazon, Netflix, voice assistants like Siri and Alexa, the list goes on. Now let's move on to artificial intelligence. So AI is a branch of computer science connected with building smart machines capable of performing tasks that typically require human intelligence. For example, robots and self-driving cars. Deep learning can be considered as evolved class of machine learning that runs inputs through a biologically inspired neural network architecture. The neural networks contains a number of hidden layers through which the data is processed, allowing the machines to go deep in its learning, making connection and weighting input for the best results. For example, conversational bots for marketing and customer services. As the data science field continues to grow, the tools and softwares are evolving at a high pace, both in terms of capabilities and diversity. So we have few tools. We have most frequently used tool for data science open platform like R, Python, KNIME, TensorFlow, Keras. In visualization, we have Tableau, ClickView, IBM Watson, even Power BI, which I have not mentioned in the slides, but yes, Power BI is one of the frequently used tool for visualization purpose. Then coming to big data platform, we have Hadoop, MapReduce, Apache, Spark, Cloudera. And when we talk about commercial platform of data science, we have SAS, IBM SPSys, Modeler, RapidMiner, and many more. Now, we will talk about the machine learning applications on various industries. So let's start with banking sector. So banking sector was one of the first adopters of data science. Analytics is playing important role in redefining banking industry in a holistic sense with applications ranging from fraud detections, predicting loan default, customer acquisitions and retentions, and increase in cross-selling and upselling. Now, we'll talk about the applications on retail industry. So predictive analytics is widely used by both conventional retail stores as well as e-commerce firms for analyzing their historical data and building models for customer engagement, supply chain optimization, and price optimization. Now we'll talk about airline industry. Airline data is collected from different sources like passengers traveling informations, census data from the plane. In today's time, airline industry must consider them as data companies first and travel companies second. Machine learning algorithms are widely used in aviation sector for personalized offers and passengers experience, predicting flight delays and safer flights. Now we'll focus on telecom industry. Telecom industry is one of the most progressive and challenging industry. The high volatility of this market is due to brisk changes in technology, especially in wireless sector. The fast changing needs of the target audience makes it necessary for the telecommunication firm to quickly adapt to the modern technology as well as align their marketing and sales strategies accordingly. Telecom sector relies heavily on advanced analytics for wide variety of applications, which include network optimization, fraud identification, and predicting customer churn. Now we will talk about healthcare industry. Data science and machine learning is playing very important role in healthcare industry in a holistic sense with applications ranging from predicting the outbreak of disease and preventive management, predicting the chronic diseases and improved patient satisfactions. Now, we'll focus, last but not the least, about the FMCG industry. And success in FMCG industry relies on sales volumes and speed due to low prices and non-durable nature of products. So predictive analytics and machine learning is playing an important role in redefining FMCG industry. Applications range from customer experience and engagement, logistic management, and markdown optimization. Now, let's talk about data. So textbook definition of data is basically collection of variables, facts, and figures, which serves as raw material to create information and generate insights. The data needs to be manipulated, processed, and aligned in order to withdraw actionable insights. There are various forms in which data exist. It can be structured data, unstructured data, and semi-structured data. Now, we'll talk about challenges in data preprocessing. So, ability to access, integrate, and utilize data from multiple sources has drastically enhanced the capabilities of data science and machine learning, but it brings its own challenges. So, integrating multiple file formats, including text, audio, and video, requires significant data preprocessing. Data in real worlds are really clean and homogeneous. Typically, they need to be incomplete, noisy, and inconsistent, and it is an important task of a data scientist to pre-process the data by filling missing values. So it is important to be handled as they could lead to wrong predictions or classifications for any given model being used. Data can have missing values for a number of reasons, such as observations that were not recorded and data is corrupted. So we can handle missing values by using various methods. Like you can mark invalid or corrupt values as missing in your data set. You can remove with missing data from your data set. Or you can impute missing values with your mean, median, mode values in your data sets based on your business scenarios. Now, quality of data also affects selections of the algorithm, which can be implemented. So certain algorithms by designs are robust to missing data, such as KNN, decision trees that can ignore a column from a distance measure when a value is missing. While algorithms like LDA and algorithm that does not work when there are missing values in the data set. So it's very important to handle the missing values before we go ahead and start modeling our data set. Next important data processing is to identify outliers or anomalies in the data. Outliers or anomalies are extreme values that fall a long way outside of the other observations. So now, why do we care about anomalies? So many machine learning algorithms are sensitive to the range and distributions of attribute values in the input data. Outliers in input data can skew and mislead the training process of machine learning algorithms, resulting in longer training times, less accurate models, and ultimately poorer results. Outliers can represent example of data instances that are relevant to the problems, such as anomalies in the case of fraud detections and computer security. Another reason why we need to detect anomalies is that when preparing data sets for machine learning models, it is really important to detect all the outliers and either get rid of them or analyze them to know why you had them there in the first place. Like I just discussed about fraud detections. In that case, outliers can be very useful information in identifying fraud activities. Common ways to detect anomalies are by going through standard deviations and box plots, by opting for robust random cut forest. Last but not the least, it's about another common problem data challenges in solving is class imbalance issues. If class imbalance issues exist and if it remain unaddressed, it will lead to misleading accuracies. And I will discuss about the various methods to handle class imbalance issues in banking use case in detail in my upcoming slides. Last but not least is about feature scaling and feature engineering and feature selection. Feature scaling is a technique to standardize the independent features present in the data in a fixed range. It is performed during the data preprocessing. So now the question is, why scaling? Most of the time, your data set will contain features highly varying in magnitudes, units, and range. If left alone, these algorithms only take in the magnitude of features, neglecting the units. The results would vary greatly between different units, like 5 kg and 5,000 grams. The feature with high magnitude will weigh in a lot more in the distance calculations than feature with low magnitude. To suppress this effect, we need to bring all features to the same level of magnitude, and this can be achieved by scaling. So there are various methods to perform feature scaling. It can be done by standardization, mean normalization, and min-max scaling. Now, what is feature selection? So feature engineering and feature selection are critical parts of any machine learning pipeline. The data features that you use to train your machine learning models have a huge influence on the performance you can achieve. So feature selection is the process where you automatically or manually select those features which contributes most to your prediction variable or output in which you are interested in. So why feature selection? Before we proceed, we need to answer this question that why don't we give all the features to the machine learning algorithm and let the machine decide which feature is important? So there are three reasons why we don't do that. The very first is curse of dimensionality, which is about your overfitting. So if we have more columns in the data and then the number of rows, we will be able to fit our training data perfectly, but that won't generalize to the new sample. And thus we learn absolutely nothing from our model. Next is Occam razors. We want our models to be simple and explainable. We lose explainability when we have a lot of features. And third is about your garbage in and garbage out. So most of the times we will have many non-informative features and redundant features. For example, name or ID variables. So poor quality input will produce poor quality output. And also a large number of features make a model bulky, time-taking, and harder to implement in production. So what we do? So we select only useful features. There are a lot of ways in which we can think of feature selection, but most feature selection method used are embedded methods. So embedded method use algorithms that have built-in feature selections method. For example, lasso regressions and random forest have their own feature selection methods. Another one is principal component analysis, which is widely used in dimensionality reduction technique. Now, let's start with our essential. Now, let's talk about essential workflows. So, the workflow of all the data science projects and machine learning projects goes through this. So, the very first step will be data collection. So, data is collected by data engineer in various forms. It can be structured data, unstructured data, and semi-structured data. And it can be coming from different sources. It can be your social media data. It can be your internal data. It can be the data which is coming from your client or vendors end. So various sources and various form. Then once the data is collected, then we move to the step 2. That's about data preparation and enrichment. So data preparation phase is actually the most labor intensive one. And all the data scientists and machine learning expert and all the data scientists, they consume average of 70 to 80% of their data scientist time and doing the data prep part. And that's the very important step in all data science and ML projects. How well data you have, how clean data you have, how structured data you have, that will result to your more effective output. Then the step 3 is modeling and predictions. Once we have our cleaned and structured data, we apply appropriate algorithms based on our business scenarios, and we access the performance and compare results and optimize our models accordingly. And then step 4, which is the final step, and that's about our execution and deployment, which produce our actionable results that can be consumed by diverse internal and external systems. Then we'll talk about classification in machine learning. So in machine learning, classification is basically a type of supervised learning. So in which the computer learns from the values of predictor variables given to it, and then uses that learning to classify new observations. This can be multinomial, this can be binomial. So few examples of classification algorithms are fraud detections to identify the fraudulent activities, loan defaulters, who are the customers who is having the high probability to default the loan, image recognitions, and many more. So type of classifications in machine learnings are logistic regressions, decision trees, SVM, support vector machines, random forest, extreme gradient boosting, and many more. So now let's start with our first case study. In this case study, we demonstrate how classification algorithm can be used for loan default prediction in banking sector. So let's take a look at the problem statement. A large banking firm wanted to find more effective ways of detecting applications which have a high probability of defaulting on loans. They only had sufficient resource to follow up on 5% of the applications identified as potentially defaulted. So they wanted to find a way to ensure to the highest possible probability that the applications referred for investigations were indeed those most likely to be defaulted. So for audience less familiar with the banking vertical, I want to briefly explain loan default and its consequences. So when a borrower is not able to pay interest or principal on a loan on time, then the person is considered as a loan defaulter. Loans can be home loan, education, personal, business, and auto loan. And loan default will cause a huge capital loss for the banks. Now, We will talk a little bit about the data here. So in this banking case study, various machine learning methods were applied for predicting probability of bank loan default. So here our default target variable is loan defaulter, whether the person is defaulting loan or not defaulting loan. So loan defaulter are highlighted as 1, non-loan defaulter as highlighted as 0. And in this particular case study, we have 88% of the customers who are non-loan defaulter and only 13% of customers are there who are loan defaulter. So in this case study, we see that we have an issue of imbalance, right? We have an imbalanced data set, right? Because our non-loan defaulters are 88% and loan defaulters are 30%. So whenever we have imbalanced data sets, right? Those where in imbalanced data sets, there is a severe skew in the class distribution, such as 1 raised to 100 or 1 raised to thousands, right? Examples in the minority cases to the majority classes. So this bias in the training data set can influence many machine learning algorithms, leading some to ignore the minority class entirely. And this is a problem as it is typically the minority class on which predictions are most important. So one approach to address the problem of class imbalance is to randomly resample the training data set. So the two main approaches to randomly resample an imbalanced data sets are to delete examples from the majority class called undersampling and to duplicate examples from the minority class called oversampling. And third method is combination of over and undersampling, where we can combine over and undersampling techniques into a hybrid strategy and then balance our data set. This is architecture of proposed model. Like step 1 goes for the data collection, then data preprocessing, selection, feature selection. And then if we have imbalanced data set, then going for sampling techniques where we are going to balance our data set, and then model building, and finally our validation part. Now, this displays the correlation plot of few of the variables which we have taken in that use case study. So we have variables known as term and employed and checking amount, credit score, saving amount and age, education loan, home loan, employed, unemployed, many more. So here our default is our dependent variable. And we see in the correlation plot that default is positively related to term and unemployed. So it means the customers who is having more term in terms of their loan, the probability of default is very high as compared to the one who is having lesser term. Similarly, the person who is unemployed is having a higher probability of default as compared to the person who is employed. Similar cases here with the checking amount and credit score, saving amount, and age. So where we see that default, which is our dependent variable, is negatively correlated to our independent variables. So that says that default is negatively correlated to checking amount. So it means if you have a higher checking amount, the probability of default will be less and vice versa. Same thing with credit score. If you have a higher credit scores, the probability of the default will be less, and similar vice versa. Same thing applies with saving amounts and age also. Now we'll talk about accuracy of the algorithm before addressing class imbalance issues. When we built model and our class imbalance issues was not sorted in our data, and we applied support vector machines, random forest, and extreme gradient boosting decision tree, we saw our accuracy percentage as 85, 87, and 88%, and specificity as 92, 93, 94%, and sensitivity as 31, 32, and 35%, right? And if we look into these percentages are not very promising because we know that we have class imbalance issues in our data. So we have to go and we have to solve our class imbalance issues by using various techniques. And in this case study, we have gone for a sampling approach, and that is undersampling. So in this undersampling approaches, we have balances the data set by reducing the size of the abundant class. This method is used when quantity of data is sufficient. So by keeping all the samples in the rare class and randomly selecting an equal number of the samples in the abundant class, a balanced new data set can be retrieved. So in this case, we are predicting class 1. So class 1 means the customers who are having high probability to default. So reducing the size of the class 0 in order to balance the data set is the better way to handle the issues. Accuracy of algorithm after addressing class imbalance issue by using undersampling. So we have again applied the same algorithm, support vector machine, random forest, extreme gradient boosting decision tree, but we have applied these algorithm after addressing the problem of class imbalances. And we can see big changes in our accuracy, specificity, and sensitivity percentage, which is accuracy 78, 80%, 81, specificity deals with 79, 81, 82, and similar you see sensitivity is now 80, 81, and 83%. And if we look into those three models comparison, we can definitely see that gradient boosting is the one which is coming up with better accuracy and better sensitivity. So this is the way our class imbalance issues helps models in increasing their accuracy and helping in terms of doing better predictions. So in summary, the solution provided was that the banking data science team combined internal data on customer data and historical credit data and tested various loan defaulter detections algorithm against this aggregated data. An algorithm that provides reliable, they set up a real-time API based on that algorithm to guide the automatic routing of applications within the systems based on their likelihood of defaulting. And the result or the benefit which were realized were the company reports that the new system of identifying potential loan defaulters has proven itself to be 4 times more effective at detections of loan defaulter than their legacy approach. And they anticipate even better performance as the model is continuously improved through the flow of real-time data. So I would like to conclude my talk with following takeaways. Data science is truly transforming how business is conducted across verticals. The most critical aspects remains the data, thorough understanding of data, its uniqueness, and how the limitation of available data on hands can be addressed governs the outcomes of the project. A toolbox approach can be assumed where various models and algorithm constitutes the tool, which can be applied across verticals to address diverse industry problems. So thank you for your time and attention, and I would be